Hi there. In this video, I'm going to show you on how to do clustering with AI agents. But first, let me explain you on what is the difference between a traditional way of doing clustering versus agentic way of doing clustering. So in a traditional way of clustering, you basically choose the clustering algorithm. You also manually decide on what fields are required. You experiment with different clusters. Then you kind of inspect the silhouette or matrix accuracy scores, and then you repeat all this process until the results kind of look useful. However, with agentic clustering, you start with describing the objective of clustering. So you can specify that give me clustering based on customers or give me clustering based on price, etc., etc. You define your objective. Afterwards, the agent is going to automatically select the fields which are most appropriate for your objective. It is also going to select the appropriate clustering approach, and then it is going to come out with the results, and it is going to evaluate it, and if it still requires improvement, it is going to iterate. So you can think of this as an analogy between a recipe and a sous chef. So for example, in a traditional clustering, it is like somebody gives you a recipe and you do not have any opportunity to be creative. You just follow step by step and you have your dish which is prepared. But in case of an agentic clustering, you have the opportunity of being creative. So you are a sous chef. You first decide what is the objective of making food. For example, it could be for a restaurant or it could be for some special events. And then based on that, you decide what are the different ingredients, what you need, and then you cook, you make the recipe accordingly. So that's a difference between the traditional clustering and agentic clustering. And now let us dive into on how to build agents which can do this agentic clustering. Let me also explain the architecture of this agentic flow. So we are going to have a supervisor agent which is going to receive all the user requests. If this user request has nothing to do with clustering, in that case, it is going to end. But if the user has given a request which is related to clustering, in that case, first of all, we are going to describe the data, and then we are going to select all the fields based on the objective of the clustering. We are going to then make the clustering and then pass the result back to end. Now, let us see on how to build this agent. So to build this agent, I'm going to use a tool called as dataset.ai, which is a tool which has been developed by me. You can develop very powerful AI agents related to data, and you can get started for free. So let us now create the multi-agent clustering architecture from scratch. So I'm going to click on new agent, and here by default, you get an agentic flow. So this agentic flow by default has got an agent, which is basically an access to a large language model, which is used for interpreting the user request or a prompt which are expressed in natural language. And it has also got access to some tools. So tools is where the actual work happens, for example, clustering. So here, this agent is accessing a large language model, and let us now given access to a large language model, which is this data Jarvis free. And let me also quickly show you on what this agent is accessing. So here you go to Model Hub, you will see list of different models which are available, and this particular model, data Jarvis free, is behind the scenes accessing this Claude HiQ model, which is a large language model. Now, let us create the flow which I have shown you earlier. So in this flow, we will first need a supervisor agent, which is going to understand if the user request is a clustering request or it is nothing to do with clustering. So let us first of all call this agent as the supervisor. And then we also need to create another agent, which is going to be our data description agent. The data description agent will also need a tool, and we will also need another agent, which is going to be our clustering agent. And the clustering agent will also need access to some tools. Okay, let us at least save this till now, so I can say that this is my clustering agent. Now let us connect all these different nodes. So behind the scenes, this architecture is getting constructed using the agentic framework called as LangGraph. It is a pretty powerful framework to build very interesting, very precise agents. And it's for this reason you can see this architecture, which is basically a connection of nodes, and all this connection is also called as edges. Right? So what you see on the front end is basically a representation of LangGraph, but in a visual way. Let us now connect all these different nodes and edges. So let us first of all try to connect the supervisor and the tool node. So here what we want to do is we want to identify if the request is a data analysis or a clustering request or not. If it is not, it should directly end. Otherwise, it should get passed to the next node. So let us here, first of all, identify the tool. So here I've created a tool, which is this root 2 analysis. And let me quickly show you on what this tool is doing. You can go to Tool Hub, and here you'll see list of different tools. So the root 2 analysis is basically a simple Python function which is going to be called only when the user is requesting data analysis, data description, or things which are related to clustering. And you should also pass a short reason of what is the purpose of clustering. Now, this tool will be called only when the request is related to clustering or data analysis. Now, what we should do is we should not pass the work back to the supervisor, but we should pass the work after the tool has finished. It is now to go to the data description agent. So we are going to take this edge over here and we can just delete it. And this edge over here is basically called when you have this tool call which is being made. So this supervisor agent is going to receive the request, and then if the request is related to data description or clustering analysis, in that case, this tool will be called, and this edge is the tool call which is actually making this tool call which is related to the root 2 analysis. Now, once the work is completed by the tool node, it is then going to pass the work to the data description agent. And the data description agent is again also going to call the tool node, which is going to describe all the data. And then this edge, we know that it is going to be called whenever there is a tool call. So we can put tool call over here. And the work is then passed back to the data description agent. The data description agent is then going to pass the work to the clustering agent. The clustering agent is then going to call the tool node to do all the clustering. So this has to be, once again, a tool call. And once the clustering is done, we are going to pass the work back to the clustering agent. The clustering agent is then going to pass the work to end. So the work is finished. So this has to be done. Right, once the work is done. Also over here, we need to pass this work from data description agent to the clustering agent once the work is done. As well as we also need to make now all the configurations of the tool node. Now, before we do that, let us also add one more node, which is the shared state. So shared state is where all these agents are going to exchange all the information. And this shared state will have some attributes which these agents can share. So let us now look into what are the different shared state variables we will need. So for example, we will need an attribute which is related to the number of clusters, which is a very useful information for all the agents. We can also add a attribute which is related to the silhouette score, which is on how accurate is the clustering results. And this is very useful for the agent to decide to continue or to end. Now, we will also need a list of columns which are selected for clustering, as well as we can also store all the descriptive statistic by the agent, which will help the agent to understand on what are the different fields which are required to make the clustering. And let us now make sure that all the agents have got the right tool selected. So this supervisor agent is going to have access to the root 2 analysis, which is good over here. The data description agent is going to have access to the data, described data set, as well as it should also update the shared state for all the information which is related to the descriptive statistic of the data. Now, the clustering agent also will need access to the clustering tool as well as the update shared state tool also. Now, let me now quickly show you this clustering tool as well as the data description tool. So I'm going to go to the tool hub, and let us first of all look at the described dataset tool. So which is basically taking a data set. It is then trying to find what are the different columns. It is then trying to find what are the numerical columns in the data set, what is the date columns, what are the non-numerical columns. It is also going to calculate the descriptive statistic, and then it is going to return back all the information which is related to the data. Let us also now quickly see the clustering tool. So clustering tool is going to take the name of the data set. It is also going to take the number of clusters as well as the columns which are required for clustering. It is then going to load the data in a data frame. It is going to find what are the numerical columns, what are the categorical columns, and then it is going to prepare a pre-processing pipeline. So this pre-processing pipeline is going to apply standard scaler for all the numerical columns. It is going to apply one hot encoding for all the categorical columns. And then it is going to apply this column transformer, which is going to convert all the columns into either one hot encoded columns or standard scale columns. Once that is done, you can apply the algorithm, which is called as k-means, for doing the clustering. And these clusters are also stored in the data frame. We are going to also make a cluster summary. We are also going to calculate the accuracy of the clustering, which is the silhouette score. And then we are going to create an agent-friendly message, which has got all the information related to the silhouette score, number of clusters, as well as a brief information of what is inside these clusters. Now, let us go back to the builder. And just to give you a recap till now, we have created three agents. One is the supervisor agent, which is deciding on what is the request. Is the request related to clustering, or it is a request which is not related to clustering? We also have a data description agent, which is describing the data, which has got access to the tool which is related to data description. We also have a clustering agent which has got access to the clustering tool, and these agents also have access to the update shared state, where all these agents are going to update the shared state, which is a way in which all these agents can exchange information. And also we have connected the supervisor agent to the tool call. The tool call is then passing the work back to the data description agent. The data description agent is going to call the tool. It is again going to pass the work back to the data description agent. Once this is done, the work gets passed to the clustering agent, which is again going to call this tool node for clustering. The work gets passed back to the clustering agent, and once this is done, you have the work which is then passed to the end node. Now let us configure all the prompts. So for the supervisor agent, we are going to use a prompt which is basically something like this: that you are a general assistant. If the user is requesting a data analysis, description, or clustering, you should call root to analysis, but do not try to do the analysis for yourself. For anything else, let's say, for example, like creating a HTML dashboard, which we will create later. Answer the user directly and completely, and do not call the root to analysis. Now, let us also describe the data description agent prompt. So once again, this is going to access the LLM, which is the Claude IQ model. And let us also describe the prompt, which will look something like this: that you are a data description specialist. Your only job is to describe the data set. You should not perform the clustering. you should just follow all these steps. You are going to call the describe dataset tool. You are then going to take the output such as list of columns and descriptive statistic, and then you are going to use this update shared state where you are going to share and save the list of columns as well as descriptive statistic, and then you should return back with a brief summary. Now, let us also see the prompt for the clustering agent. So the clustering agent prompt would look something like this. That you are a clustering specialist, you should run after the data description agent is finished, and you should do the following things. You should call the clustering tool, and you should use the list of columns, and you should use a number of clusters, and you should also update the shared state with number of clusters and silhouette score, and you should report back the number of clusters and silhouette score. So now our prompts are configured, and let us now save as well as validate the tool so that we are sure that everything is correctly wired. All right, so we have a valid flow, which is good. Congratulations. And let us now start trying out our agent. Now, before I do that, let me first show you the data set on which we are going to run this agent. So this data set, you can see it in the data hub. So I'm going to use a data set which is based on vehicles, cars data. So this data set has got different information related to the vehicles, such as the make of the car, the fuel type, number of doors, etc., etc. And it has also got information regarding the size of the cars, as well as it has got information related to the price of the car. So let us now start chatting with this agent, and let us first of all give a chat such as make clustering on the data set cars underscore data with an objective to make clustering for price. Right, so our objective is price. We want to make clusters of all the cars based on the price objective. So now, as you can see, that it has identified that the tool to call is the root 2 analysis, because this question is related to clustering. So we are going to approve this tool, and this is also called as human in the loop. Now the next step is to describe the data set. So I'm going to again approve this tool. And here it has described the data set. It has found various information related to the data, such as number of columns, rows, as well as data description. And then now it is going to update all this information in the shared state. Once that is done, it is now going to go into the clustering. So you can see that it has identified that the columns to use for clustering are price, horsepower, engine size, curve weight, and number of cylinders, because these fields are important to decide the objective of clustering, which is pricing. So this is really powerful. The agent is deciding for itself what are the fields which have to be used based on the objective which has been specified. So I'm going to again approve this request. And here you can see that it is now going to go and call the clustering tool. And here the clustering is done. And as you can see that it has correctly identified the clusters based on the objective. So the cluster 0 is the low price cars, and it has also given the average price, the characteristic, fuel efficiency, and size. The cluster 1 is related to the high price cars, and cluster 2 is related to the mid-range cars. So this is pretty powerful because it understood your objective of the pricing. It understood that what fields I need to select based on the objective, and then it has also given the clustering as well as a very nice interpretation. Now let us ask another question, that now make clustering with objective of size. So let us now see if it is able to identify different kind of fields. So once again, it will go to the root 2 analysis. So I'm going to approve it. It is then going to also go and identify the different fields. So here you can see that it has identified fields such as the wheelbase, length, width, and height. So this is different from the fields which were chosen during the pricing objective. So I'm going to go ahead and select this. And it is then going to go ahead and do the clustering. And voila, here you can see that it has now created a cluster which is based on the compact small cars, which is based on the cluster 1 is related to large cars and cluster 2 is related to mid-size cars. So this is pretty powerful because it understood your objective and then it went ahead and selecting the right fields to make the clustering. Now let us ask a question which is not related to clustering. So we can say make a dashboard which has got 2 tabs. First tab is related to the clustering with price objective, and second is clustering with size objective. And we can say that make it in dark mode. Use the results what you already have. So now it is not going to go into the data analysis and clustering analysis. It is directly knows that this is a request which is something else, which is related to HTML dashboarding. So it is directly going to use all the information which is available in its context, and it is going to come out with a nice looking HTML dashboard. And you can see that here it has produced a nice looking dashboard which is pretty powerful. So it has got 2 tabs. One is the clustering price objective, and then you have clustering in size. And inside this, it has got information related to the budget cars, premium cars, and mid-range cars. And then it has also given a very powerful key insight, as well as you also have the clustering with size. And in this case, this is related to the compact cars, full-size cars, and mid-size cars. And it also given a nice looking key insight, and all you can see, all this is in dark mode. So this is pretty powerful, and as you can see that agentic way is completely different approach compared to traditional way. And I would like to give you these 3 key takeaways. So first of all, prompting, it replaces some explicit logic. You have to have a nice prompt. It's very important that the prompts are very clear, and you should treat clustering agentic as some conversational with some goal-oriented approach. Like goal is to make clustering for a specific objective. It is not just coding and precising everything we know want the clustering to be done. So it is a goal-oriented topic, and your agents are going to make sure that they all work together in order to achieve that particular goal. So please try this out on datajarvis.ai and let me know in case of any question. Just ping me and I can help you out. And hopefully you like this video. If yes, please do not forget to subscribe to the channel, like and comment, and see you soon in the next video. Bye.